Hey, hello. Okay, we're live now. Okay, let's share on Twitter and LinkedIn. There we go. There we go. Okay, so hello, I'm Jorge Escobar, and today I'm going to continue with my learning process with Python, and I might like to practice decorators a little bit more, so maybe we should try to do that right now, because I think that decorators, I don't feel comfortable. I don't think that I understand them very well. So let's try something here. Let's see, where were we? Oh yeah, about this. Yesterday I went to some lengths to upload this Git repo in GitLab. So now it's being hosted in GitLab. I'm going to post the link on Twitter at the end of the day, I think. Just give me a minute. There we go. So what's the idea now? What's the plan? I created here some new, let me see if I can make this a little bigger. Wait. I'm going to need another keyboard because the Bluetooth keyboard I'm using is a Logitech, and it's not, I don't really like it because it has very few keys. There we go. And, oh wait. That was the wrong computer. Anyway. Okay, I'm back. Wait a minute. I don't really like to... Just trying to fix my setup right now. Let's see. And here we go. I think we're ready now. So let me see if I can make the user interface a little bigger. So I am ordering the my exercises and my files into folders, directories, may I say, since I'm working on Linux, you know. So I'm trying to sort the files inside these directories. And well, for the decorators, I should probably start using numbered prefixes. I also using Git for this. I created a main branch where everything is going to land, and I'm working on section 9 at the time. So that's okay, I guess. I'm not going to order this. Well, maybe I do right now. Let's try to see what decorators are all about. And here we go. This is a decorator example that I did the other day. Okay, very well. So what do we have here? Well, first, I wonder if I can mute myself a little bit because I may like to show. There we go. I think that's a way better place to be with my webcam, you know, because of the fact that you can now see the status bar. Anyway, my decorator. This is a generic decorator function that he used to explain the basics of decorators. But this is not the actual decorator pattern that he called. He called it a pattern, but this is not a decorator pattern. It is a decorator because it's fulfilling three conditions. The first one is that it receives, it needs to be a higher order function, a decorator that is. And in this case, is fulfilling three conditions in order to be selected to be a decorator, like this one here. And the first condition is to receive a function as a parameter. So it does have this as an argument. Well, it does have this parameter here called function, and it's going to receive any. In this case, it's going to receive a function itself. That's the first condition. The second condition is that I need to define a function nested inside this decorator function. And this is going to be called a wrapper function. I'm going to define a wrapper function, and it's going to be a wrapper like a gift wrapper, in the sense that inside this definition, inside this wrapper function, I'm going to be calling whatever function I pass as an argument here. In this case, it's this function. So I'm making the call in line number 8. In line number 8, I'm making the call for this function. Maybe that way you can actually see it better. And well, in this case, the only extra functionality that I'm doing to this function is to print this line of asterisk right before and after the function call. And down here, I'm defining a couple of functions and applying them the decorator. And in this case, for example, if I remove the decorator in both of these functions here, wait, what? Okay. If I remove the decorator, I'm just going to comment it out, and I try to run. What is the terminal? If I try to run the, I need to move my keyboard. The keyboard is way too big for my liking, but anyway, this was my wife's keyboard, so I do have some attachment to it now. Decorate. Wait, what? Oh, wait, I am on the wrong folder now. So, sectionate decorators. There we go. Okay, now I'm going to, there we go, execute this. And when I execute this, I'm just printing hello and printing bye, because that's what the functions do. If I enable decorators for the say hello function here, and I run the program again, now I'm getting the extra functionality. So that's the idea of decorators, is to add functionality to your own functions. And this extra functionality might include things like execute this function if there is a let's say print this message if the user is authorized, and you may send you may have a dictionary with an attribute called value or called authorization. If that's true, then you are allowed to execute the function. If it's false, you are not allowed. Things of the matter. And I've been told that I had seen decorators before. I have used them, but I didn't know how they actually work. It's like using methods in object-oriented programming, and you are just using the methods. You don't really know or care how they work. You just use them. So this is the first time for me to write in my own decorators. So this is the first exercise, I think. So there is some changes here. Oh wait, if I enable the second one, there we go. Okay, no changes now. Now I can see here, let's make this a little bigger. now I can see here that I'm printing the hello function, and I'm printing the bye function here, and I'm getting the extra asterisk lines over here, before and after the execution of the function. So that's basically what decorators are functions that are basically decorators are these marks over here that allow you to add extra functionality to your own functions. Okay, let me try to reset the zoom level. Control numpad 0. Okay, let's try that. There we go. Thank you. Okay. So no changes on this one. I may like to rename this afterwards. So my second one, exercise decorators. Okay, create an authenticated decorator that only allows the function to run if user 1 has valid set to true. And we have a dictionary here. Let me zoom in a little bit. And actually, let me fix my webcam again. Well, I guess that information is not really that useful. But anyway. So here we are. We have a dictionary here with two attributes: name, which is a storing a string attribute, and valid storing true. And down here we are printing. We are on line 22. We are executing a function called message friends, and we are passing as an argument the user1 dictionary that contains all of this data. Now, the idea is that when I execute this function here, line 22, if the valid attribute is set to true, then I'm getting this message over here. If this value is set to false, I'm not getting anything here. So that's the idea. So the function itself does not contain the logic to do just that, you know. What I mean is that if I'm not using the decorator, I'm going to comment this out, and I'm passing by the user as an attribute, and I'm executing. So I guess that I can ask, you know what, do this if user, and I know this is a dictionary, so I'm going to ask if the valid index, in this case the dictionary index is this one here, is the key value pair. It's basically, this is the key, is equals to true. Well, I don't really need to evaluate that because the actual value is Boolean already. So I'm going to ask if user is valid, and I need to do an else here because you know, I can print something else or just return false. I guess that's okay. So what's going on here? Print has been sent. User. Yeah, I don't understand what's complaining about, but then never mind. Okay, it says parameter any expression print has been sent. Is user valid else false is assigned to nothing. Yeah, that's okay. I don't really need to assign this to anything. I wonder if this thing wants me to return something. Well, this is an expression, yeah. But in this case, I just want this to... Oh, never mind. Well, the thing is that it's going to work. Let's view the terminal again. And there we go. The message has been sent. What happens if this is false? Nothing happens. It's not printing anything. So that's the idea. So the question will be, well, if that's what you want to do, why not just keep it this way? Well, the idea is that if I want this same functionality in any other function, I need to implement the very same thing all over again, copy pasting stuff maybe. And the idea of using decorators is to just write the logic once, and you know that many other functions are going to be implementing the same logic. Well, instead of copy pasting the same logic, you can basically just implement it once and add the logic as a decorator. So instead of doing this, I'm going to remove all of this. There we go. And I'm going to restore the decorator, authenticated decorator, and try to analyze this one more time. So just as before, we are getting the decorator function, which is receiving a function and is returning a function itself. Those are the requirements basically. And it's calling a function. That's another requirement. Well, this is a decorator pattern, which is pretty different than before, because in this case, the wrapper function is receiving a list of arguments and a list of keyword arguments in pass, which means that I might add any number of arguments on the wrapper, and this wrapper is going to use those arguments to send it back to the call of the function itself. So for example, instead of just printing a message here, one of my things will be, okay, well, maybe I wonder if I can actually add more things to this message. That will be one of the things I may like to do. Because if you recall, you are sending something here. Well, this is a wrapper function. The only thing that is going to be evaluated here is this, with an if statement. It's asking if the first argument, you know, is printing valid. Okay, do this. If not, don't do anything else. So, but in this case, the thing that I was not very sure about is this part over here. On line 12, I am assuming that the first element in the args parameter is going to always be a dictionary that contains a valid index or a valid key. So, or a key name valid. So I don't know, I think this was a little bit of cheating, I guess. It's not generic enough for my liking, but it is an exercise in the end, so I guess I should not be too picky about it. Oh, wait. Okay, anyway, I may need to get more coffee. I got a new mug for my coffee. So, oh wait, I need to, let's do something really quickly. Maybe not rotate, but flip horizontal. There we go. There we go. I wonder if you can read this one. Café Garat. It's an okay brand. It's hard today. These days, it's really hard to just find an okay coffee brand. They are predictable. It's an okay coffee. It's not exceptional in any way. But I'm so tired of tasting mediocre coffee that that doing the job the right way has become just being okay has become an achievement on itself. Yeah, we are in that timeline, I guess. This year is 2022 is not going to be my favorite year for a long shot, but anyway. So, well, now the thing that I want to experiment now is that this thing is passing by arguments and keyword arguments, but my original function is only receiving one parameter over here. So I'm not going to be able to, to pass any more arguments, I guess. So I got to receive the function, the wrapper function is going to get in. I guess that I might, I don't remember the order really, but I might add my own args parameter here. Is complaining already. Why? Okay, so this is the thing. I need to remember the order for the parameters when I'm using args. So it doesn't matter. This should fix it. There we go. Now, if I'm using this, now I might like use for message in args, or maybe use the singular args. For arg in args, now you're going to print whatever arg. Oh wait, no, this is a pointer. There we go. And that should do it. Probably print the index or a counter here. I don't know. For example, but I wonder if this functionality may be added right here, Well, I know I can print it here. I wonder if I can move this function. Well, let's try to see if this actually works, Right now it's going to do the same thing. It's not going to print anything. So let's change this to true. Now it's going to print something. Message has been sent. It's printing something. What if I call this with some other hello? This is a test. Have a nice day. This is oh wait, these are parameters, but okay, yeah, the user is the first one, and then I'm getting just a list of arguments. Something is going on here. I don't know what. Takes one positional argument, but 4 were given. Not really. Yeah, because it's positional. Yeah, he's right. I need to define this as user. So user 1 is going to land on user, and the rest are going to be positional. There we go. Oh, now he's complaining about the rest. Okay, let's see what it's going to tell me about it. There we go. Positional argument follows keyword argument. What? So the order is wrong. Yeah, I know. Let me see. What's this called? Args. Yeah, maybe it's not in 6, it's in 7. List comprehensions. This is important, by the way. List comprehensions. And I forgot about this already. Wow. Yeah, I think I need to go way back. Inheritance, maybe? Superlist? No. This was on 6. I do remember I took notes on the order, on the proper order for creating arcs. And it should be around here somewhere. I can't find it. Yeah, maybe it's in 7. Land expressions, okay. Comprehensions. Zip and reduce. I can't find it, actually. Wow. Maybe I did this as an exercise on the website and I didn't save it. Yeah, more probably. But never mind. I don't really need that. Uh-oh, did I close the... There we go. So I wonder if this is okay. This is not a positional argument anymore. So let me see. Let's go to Google and look for Python. The parameter order. Thank you. Yeah, I think that I'm doing something wrong with the parameter order. Let me see. What? Okay, thank you. Keyword arguments. Yeah. I guess I need to go way deeper. Oh, interesting. I didn't know. I didn't knew that I could do this. Real Python. Wait, so where's the definition? Never mind. Thank you. Okay, here we go. So I guess, oh yeah, double asterisk is for keyword args. So I'm doing this wrong. So this should work. And yeah, I forgot about it. I guess that now, I wonder, let's check out the order. Positional arguments first, I think. Then arguments, then keyword arguments, then, oh wait, no, well, asterisk arguments, positional first, I guess. This notation. Okay, so this is the notation. So the positional first, I guess, then args, then one single keyword argument, and then the list of keyword arguments. So in my case, this should work. And it's already it already removed the issues that I got here, so I guess it's okay now. And there we go. There we go. So here we have the messages. Here we have the messages. But this logic is inside the function itself. The thing that I would like to have is something like this, maybe. I'm going to remove that from here. And I wonder if I can before returning, because it's going to, you know, I may like to print a list of arguments, maybe. I wonder. I guess this is going to include from 0 onward. Well, let's see what happens there. Yeah, it's going to include the first element, which is, in this case, it's going to be the dictionary itself. But anyway, well, I'm going to try to keep making experiments with with decorators. Right now I'm going to take a break and I'm going to be right back. Okay, I'm back. And well, I guess that was a good practice, I guess. I wonder if I can make this run ignoring the first element, but that's like cheating, I guess. Yeah. Well, because it's going to print the first element in the list. Oh, wait, there is a new update. Oh my God, I swear. I wonder if I can link this to... Okay, let's see, downloads. Yeah, I guess. It's already downloaded. Whoa. That was fast. Okay. Yeah, I wonder if I may have Visual Studio Code installed from APT or something similar. Because, okay. I guess now I already did. Let's close it and open again. And I think that I have the recent version now. Okay, thank you. Anyway, wait, the font looks weird. It's the same font? Yeah, I think it's hack. Okay. Okay, let's make sure. Yeah, it's the hack font. There we go. Anyway. I guess I should take a new selfie picture for my profile pictures all over the web, you know. GitHub has an old picture of me. GitLab has an old picture of me also. Well, the functionality has been added right here. Okay. Well, I'm not going to leave it like this, so I wonder if I can just discard the changes. Yeah, don't save. There we go. There we go. We have the original. Okay. The original is back. Never mind. Okay, so let's begin with section 9. Let me transform again. Flip horizontal. There we go. So it makes sense when I take a look back here. I swear I need to find to fix. I have a monitor here dedicated to monitoring myself, but the little the screw hole got broken, so I'm no longer able to screw it anywhere else. I'm trying to make it sit somewhere, but it doesn't make any sense anyway. Okay, so here's the thing. Let's go back to the website, to Udemy. And decorators, there we go. So let's begin with decorators, but I'm going to be here the entire day, or as long as I can, for reasons of, well, I'm no longer assigned to a project. And I'm pretty confident that I'm going to be notified to be laid off from my company. So in the coming hours, so I guess I'm going to use this as an opportunity to focus myself on learning Python. I have very little money saved because my dad and my grandpa and my grandfather. I basically gave them some money there. So, after my wife died, well, I went broke. I don't resent that, actually. going broke because you can always make more money. So it's not really that, it's not really an issue. Well, now, but who knows? Well, the thing that I'm going to change, I'm going to set a Pomodoro app right here. And this app, I wonder if I can link it to my... Yes, I think I can. I don't think I'm going to try to do that right now, but maybe. Let me see. If that's fast, I'm going to do it. I'm going to be using a Pomodoro Club app. Let me see if I can do that. I do remember that years ago when I bought my phone, there was an app that allowed me to basically stream via Wi-Fi whatever is happening on my phone. But this was an app, Smart View. Your Galaxy's phone screen with a Smart View. But I'm not using a recent phone. I'm using a Samsung Galaxy. S8. So this phone is from 2017. So it's a really old phone right now. And I might like to... There was an app. I don't remember the name of the app. And I wonder if I can screen share. Screen share the Windows PC. There we go. I think I found it. Smart View. Do I have that? I don't think so. No, I don't see it. Smart View. I see a Smart View. It's an app now. Okay. Okay. I do have a Smart View. It's showing me things, but I wonder how do I Smart View directly into my PC. Okay. Wired. Mirroring from your Galaxy is still possible if you don't have a smart TV, but you need a Samsung USB-C to HDMI cable adapter. So my phone is not going to, well, my phone is working. I see devices here, but my computer is not one of them. To your PC, there we go, Sizing, that's the name of the app. There we go. Let me show you what I'm looking at. What sloppy of me. What? That's not working. Okay, let's go to studio mode. What's going on here? What's going on? PC test. Oh, wait, yeah. I no longer have this one. Which is weird. I don't see a number, but let's just call it like that. There we, oh my God. The cables were swapped. That's what's going on. I didn't do that, did I? There we go, yeah. The cables were swapped. That's what was going on. There we go. So this is the app. Okay, did I download it? Yeah, I don't think it's downloading anything. No. By some reason, it's ignoring me. I think it's already gone. I don't think they are supporting the app anymore. Oh, never mind. It's going to be replaced by something called Samsung Flow. Driver download. Do you need a driver for that? So, okay, so it's been replaced. I guess. Wow, so much complexity. Well, sizing in the ancient times was used to stream your video from the phone to your computer. And basically, I use that to stream apps like the Pomodoro clock and other things like Twitter feeds and whatnot. And I'm saving my only HDMI input port for capturing video from my Linux computer, you know. What? Okay. So let me see. Smart View is not. So Samsung Flow, I think it's called. Let's see. Let's look for Samsung Flow. I guess I need to open. I have the app. I don't remember installing it, but I have it. There we go. It's looking for devices. Okay. I don't see my device here. Maybe I on another Wi-Fi network. Yeah, that must be it. There we go. That's it. Okay, let's switch to the 5G Wi-Fi. Yeah, there we go. Now I see myself. Okay. Yes. I need to push something or... Okay, let's go back. Yeah, it's the same number. Nothing is happening. Oh, wait, I need to click here. Never mind. Okay, looks like, yeah, I guess. Allow everything. Yeah. I guess I need, I don't know what else do you need me to do. It seems like it's connected, but Smart View. Okay. Okay, I lost connectivity on my phone, I guess. What's this? Oh, this is side view. So they basically, they didn't replace it. They basically encapsulated side view inside all of this thing. So it's more sophisticated than I like to think. This is for turning on and turning off the screen again. Okay. I wonder if I can change resolution here. Yeah, let's go for high. Why not? PC, phone. Yeah, it's okay, I guess. Notification for Twitter. Oh, let me guess. I need to drag. Oh, look at this crap. Oh, new episode from one of my favorite podcasts. Okay. And Twitter junk. Twitter shitposting is one of my favorites activities to do. Okay, so I can use this window now. I wonder if I can just... okay, I guess I need to keep that one open. And this is the app that I want to show. Can I minimize that? And now, I may like to try to... Give me a minute here to create a Samsung Galaxy SA Plus. A scene and choose that window. What is the window? Window capture. Okay, so now I don't think that's the window. That's not the window. It's not the window. What is the window? Samsung Flow. Oh no. It's not. They are both sharing the same name, but I cannot. There we go. I see it now. Thank you. Okay, thank you. And there we go. Now, if I go back to my main scene, now I guess I can add this scene. It's going to have one of those long ass names. There we go. Yeah. And there we go. I'm going to change it right now. Let's see. There we go. So all of that time and effort just to do this. Why not? Well, this app is my Pomodoro app, basically. I really like this one because it's the best one out there for Android at the time. Well, at the time when I get it back in 2017, it's really great. So the idea is that the second I push this button, a clock is going to run down from 25 minutes down to 0. And when that happens, then another clock for 5 minutes is going to start. So this is a 25-minute work session. That's the idea of the Pomodoro technique. So when this run out, I'm going to take a break for 5 minutes. And here's the 5-minute clock. I wonder if I can change the color of the clock depending on... well, I already upgraded this. Yeah, I already paid for this. I don't think I'm going to be... okay, let's see. Change background for break. Yes, and I going to this green thing. There we go. See? So I already know that when the clock turns green, I'm already on a short break. And now, okay, I just say, okay, save, thank you. Okay, what else? Cancel? Oh, okay, I guess I need to push cancel anyway. Change background for bit break. You are going to be blue. Happy Fisher. There we go. Cancel. So I'm going to have 5 minutes of a short break where I can stand up, go somewhere else, get some coffee, play a game, and that's what I'm going to be doing today. I'm going to be playing a game. Probably on my Nintendo Switch, because I had abandoned the Nintendo Switch a long time ago before my wife died. So I haven't really played that. And this is the work session is in red. Break is in green. Work session is in red again. Another break, and every 4, I believe it's every 4 work sessions, I'm getting a bit break. This is going to be a 15-minute break, and then the cycle itself repeats, you know. And that's basically the idea of the Pomodoro technique. So I'm going to fix this this thing over here. Let's transform it. Well, actually, I can just okay, let's make it shorter over here, and there we go. And I guess that what I really need is this section over here. I don't really need it to be that tall. Well, the color is showing me what I am at, so I guess that the only thing I need is this thing here. Is the watch itself. There we go. It's nice. I wonder if I should keep it that big, because it's going to take some space, but anyway. Let's try it out like that and see what happens, okay? So that clock over there is going to be running. Let's put it to run. There we go. So the idea is to get work done in a focused manner. So let's do this. Let me move my window over here, because it's taking some space now. I wonder if I minimize the window, it's going to happen it's going to... Now that was one thing I was afraid. There we go. That the clock stops because I minimized the window. Yeah, I'm going to keep the window open anyway. I need to put it back in the background, I guess. There we go. Well, let's get back to work then. 1 minute passed and I'm not doing actual work. Okay, let's begin.
An unavoidable part of being a programmer is that your programs are going to give a lot of errors. You can't avoid bugs. You can't avoid programs breaking. A simple print function here with, let's say, a misspelled word with, let's say, no comma. If I run this, we've been seeing this a lot, right? We've been seeing a lot of this red throughout this course. A lot of these errors. If I try to add 1 plus, let's say, true, click run, that works. But then all of a sudden I decide to add hello to 1. And yet again, we see that red, this time a type error. An error that crashes our program like this is called an exception. And Python raises these exceptions whenever the interpreter says, hey, I have no idea what you're doing. Something's wrong. I don't know what I'm doing anymore. I'm going to stop whatever I'm doing and I'm going to give you an output. This is bad because right now we're just playing. But if we're Google and people depend on us to maybe check their email to watch YouTube videos, if our programs have exceptions and they stop working and they error out, that's bad. That could cost companies millions. So how can we handle these exceptions that crash our program? Well, we need something called error handling. It's a natural part of being a programmer. And a great programmer is able to handle errors in their program. Because instead of letting our programs just error, we're able to handle them so that if we get something like a type error like this, we can actually handle that error within our programs. And in this section, we're going to learn all about that. But the key takeaway is that error handling allows us to let the Python script continue running even if there are errors. Sounds pretty interesting, right? Well, before we get into that, let's just talk about some of the errors that exist in Python. We've already seen type error, where we're trying to do something between two different data types that are incompatible, such as adding int and string. And these built-in exceptions in Python, there's lots of them. And I'll link to this resource so you can take a look. But if I scroll through here, you see attribute error, end of file error. We keep going. We have a name error. We have so many errors, reference errors, just a ton. Let me just go through some of them that are quite common. One is a syntax error. If I do def and let's say hoo, and I forget a semicolon here, and I run this, I get a syntax error. It's not a standard Python syntax. I have to fix my error. I can also get something called a name error. If, let's say, I use 1 plus name like this, and I click name like this, you can see the red underline here. I get undefined name. So that if I run this code, I'll get a name error. Name is not defined. We've seen type error. But what about this? What if we have a list, let's say li, 1, 2, 3, and I access li, let's say, an index of 5. If I run this, I get an index error. List index is out of range. What if we had a dictionary? So let's say we're creating a dictionary here. We'll say a equals 1, and we'll just leave it at that. So this will be a dictionary. If I do dictionary here and just try to access something that doesn't exist and I click run, I get a key error because I'm accessing a key that doesn't exist. We can also have, let's say, 5 divided by 0, which should give me a 0 division error because I'm trying to divide by 0 and, well, you just can't do that. So there's lots of errors or built-in exceptions in Python. Now, you don't have to memorize any of these. Most of the time, they'll come up in your program and you'll know what they mean, but you can always use this reference to read them. The question you should be asking yourself is, how do we avoid these? Because most programs aren't just
I see what it is.
Usually programs interact with the outside world, right? When I log into my email, I let a user use their email and password. When I play a game, I let a user control a character. So programs are constantly interacting with the outside world, and they have to make sure that whatever input they get is the right type that they're expecting. Because if they receive something that they didn't expect, like number, and this number just happens to be, let's say, 0 that we give it, well, this user broke our program. So we need to handle these situations where a user might give something bad that we wouldn't want. In the next video, we're going to explore how we can handle our errors. I'll see you in that one. Bye-bye.
Okay, error handling.
Error handling allows us to let the script continue running, even if there is an error. Let's try an example to show you how we can do error handling in Python. Let's say we wanted to create a program that allows us to take a user's input. Let's say that we ask the user for an age. So we use the input prompt and say, what is your age? And then here, all we're going to do is just print the age. Nice and simple program. If I run this and I type in, let's say 10, there you go. Everything is working. But what if I didn't enter a number and I go like this? Well, that still works, but is that what I wanted to do with my program?
No.
Maybe I wanted to enter the age and calculate if they can play the game or not, whether they're 18 and over. How can we fix this? Well, one thing we can do is just to wrap this in an int, right? So we convert whatever the user gives us into an integer. So that if I run this,
You're going to break.
oh, I get an error, a value error. Invalid literal for int. I'm trying to convert this into an integer, but it's telling me that's an error.
Doesn't work.
So how can we fix this with error handling? In Python, we can do it this way. We have the try keyword, which says, hey, I want you to try this piece of code. And we have to make sure we indent it. So we try this piece of code.
It's a block.
Anything that happens inside of the try block, I'm able to handle, see where handling is coming from errors, with the except keyword. And except says, hey, if whatever's in here in the try block, if anything
fails,
I want you to say something. So instead of having this red error that exits out of the program, do something else, do this. So I'm going to say, print, please enter a number. Let's see what happens now. If I click run, what is my age? I'm going to just write gibberish. And look at that. I get, please enter a number.
And it's repeating. Wow.
By wrapping all of my code.
No, it's not repeating. Okay.
So I could have just copy pasted my entire file here, put it inside of a try block. And what's going to happen is instead of my program erroring out before my program crashes, it's going to run this code and then it's going to say, hey, if within this block anything happens, well, catch it in here with the except.
Catch it here.
I can here do it. In my case, I can say, hey, please enter a number. But we have a problem here, right? The program just ended and we want this to keep running. I have to click run again and ask for the age once again. So how can we make sure that we keep running this until, well, the user actually enters something valid? Well, we've seen this before. We can do a while loop and say while true, run this. And if this works, well, we're going to hopefully get the age. Let's see that. If I click run, what's my age? Let's say, nope, please enter a number. What's your age? Let's try to break it again. Nope, please enter a number. All right, fine. My age is 10. There you go. I get the name 10, but oh, it's still asking me what's my age. Ideally, I want to break out of this true statement, right? So how can I do that? Well, I can use what we call in here an else block, which we've seen before. But this works with the try except block. We put it at the end. It says, hey, try this. If there's an error, do this. However, if there is no error, else.
Yeah, there's no error.
So in our case, we can just say break.
Oh,
you know what? I can even print. Thank you. Just so we're nice. If I stop this and run again, and I give them my age, there you go. We're done. We broke out of the loop, and everything is good. And this try except else block can go anywhere. We can wrap our entire file in a try except else block. We can just add it into our functions, inside of our each individual functions. Whatever we want, we can use. This is just another tool that Python gives us to handle errors. But let me ask you something. What if I did, instead of print age, I did, let's say, 10 divided by the age? If I run my program, and I type in here 0, and I enter,
Yeah, it's going to.
I get an error. Please enter a number. But I did enter.
You don't know.
This is a buggy program. Although I'm
Yeah.
a number, it's still giving me the same error message. So how do we handle this? How do we handle different errors? One where it is a value error, and another one that is obviously a zero division error.
Zero division, yeah.
In the except block, I can simply give it what type of error I want to handle. And remember, these are built-in errors. So in my case, I want to say this is for a value
error.
If I run my program and I type in 0, I get my error.
Zero division error.
Value errors. Any other errors, it does not care about. So what can we do here? Well, one option is to copy here and say, hey, let's add another except. And in this case, I want a zero division error. In case a user enters 0, you can say, please enter age higher than 0. So that if I run this now, and I do 0, I get please enter age higher than 0. If I do some gibberish, I get please enter a number. If I finally enter a number, look at that. Thank you. Everything is working. Now here's my question. What happens if we enter another value error here? And this value error is just going to say exclamation marks. What happens now?
The first one is going to run?
I get please enter a number. Because this except block is going to run only once. As soon as it catches the error it's looking for, it's going to run and then come back to the while loop. So only one of the errors will be caught. Okay, let's take a break and learn more about error handling in the next video.
Okay, I think I should at least write down. There is a resource here. Oh yeah, for the list of exceptions. Arithmetic error, buffer error, concrete exception. I guess these are the general errors, and these are more specific. Assertion error. Look at that. These assertions are already inside the exception handling. There we go. Okay, so I'm going to at least type down that one. I'm going to need a new folder over here. You're going to be section 9. Advanced Python error handling. Okay, error handling. I'm going to put it. I'm going to give it a number in order to know in which order I'm making this file. So let's say error handling sample.py. Okay, let's insert that one. Okay, no longer needed. There we go. You should be able to read that one. And here, let's see, what did he do? Okay, he tried it. It's the while loop, while true, and he's using the else to break out of the while true. Okay, it's a try. Okay, let's see. While true, and here he's getting a try catch. Well, in this case, it's going to be a try exception. Okay, so it's going to ask for an input. Okay, age equals, I'm going to cast as an int whatever this input. Function is going to ask what's your age? Oh yeah, I need to escape this one. There we go. What's your age? And then it's going to divide. Well, 10 divided by the age. I wonder if I need that right now. I don't think so. And the first exception. The first step is going to say, well, it's for value error. That's the first one. Value error. Please enter a number. That's the first exception. The next exception is going to be division by 0, I think. 0 division error. Okay. A 0 division error. Well, I guess I can just copy paste this one. 0 is not a valid value. Okay, and then we have the else. The else. And here, well, he's printing thank you, why not? And he's breaking out of the loop. This is the else. Okay. So let's run that. I need to go back one level. Section 9. There we go. Python 3. What's your age? I'm 40. At this time, because in some days at the end of this month I'm going to be 41, and I'm going to be officially an old man. Well, I already consider myself at least a middle-aged man, but I enter in the old man category really soon. What's your age? 40. What's your age? 0. 0 is not a valid value. What's my age again? Please enter a number. What's your age again? 40. Thank you. And that's it. It's pretty common. I'm really glad that we have access to this else, because we are able to use this in JavaScript and in Java and in C++ and others. But this is the first time I see else explicitly, basically. So you just capture whatever exception happens, and that becomes your else, you know. But here you are able to specify what may actually happen, and in this case he's printing messages, but this can be used very easily to correct the data, and or at least give some warning to, you know what, I'm going to use a default value for this data that you try to enter, or something like that, you know. But anyway, I guess that's it. I am on section 9. I'm going to add this thing over here. I wonder if I can just copy relative path for this one. I tried yesterday and didn't work. Well, not yesterday, I think it was past Sunday. There we go. Okay. Let's continue.
Let's try a different example here. Let's say I'm creating a simple sum function. Yes, I know it already exists in Python, but we'll just create our own. A simple one that takes num1 and num2. And in here, we'll just return num1 plus num2. Now, if we were to just simply do sum1 and sum2, and I ran our program, well, let's print it out first.
Yeah. It's going to concatenate them.
I get 1 and 2 because it just adds the two strings together. So let's just do this and click run. I get a type error. Must be string, not int. So based on what we learned, how do we handle this? Well, we can add a try block in here and wrap this function, or we can build it directly into our function. So I can say try this part, and here have an except clause that says perhaps if we get any type of error, we'll print something is wrong. If I run this, I get something is wrong. But here's the problem. By just doing except with no exceptions, as a programmer, I'm reading this and I don't really know what actually went wrong.
What happened?
Because it can be so many things. So a good practice is to always catch these errors based on a specific exception. This way, you know what the error is and you can be more descriptive. So here we can say type error, and this type error, we can just say, please enter numbers. So that if I run this, I get, please enter numbers. So now, all right, my error is more descriptive. I should fix this and make sure that I enter numbers. Awesome. Now, a common pattern when doing error handling is to do something like this. Type error as, and then doing something like a variable. So whatever variable we want. In our case, let's just say error. So I'm saying, hey, if you catch type error, let us use error in our error message. So I can say here, plus error. So that if I run, and let's do a string here. If I run, look at that. I get the error printed. Let me just open this up a little bit so you can see clear. Look at that. It actually gives me the error that I
Well, I just received a message from HR, and I do have a Teams meeting this in a couple of days. So I guess I'm going out. I don't think I'm going to remain in a center, but well, anyway, I already knew that, I guess.
So that I can see that on line 5, on this line, I get a type error, unsupported operand. And I get a descriptive error of what is happening. So maybe I could use it in my output message. But what if I don't want to use this? And I do run. All right, everything is working. Again, if I do plus, error, and I click run. And this is actually tricky, but it says here, during handling of the above exception, which I'm doing, another exception occurred. Oh boy, I tried to handle something and I had an error within that error. So this is sometimes tricky, but what it means is what we get out here is actually an error object. It's a built-in exception in Python. You can't add in here the way I have. Instead, we want to use an f string. So I do f, and then here pass it the error. So that now, if I run this, I get please enter number, unsupported operand, type s for plus, int, and str. So I actually get this error available to me. Now, if I was to just print this error, let's see what it looks like.
Okay, let's look back a little bit.
And str. So I actually as, and then doing something like a variable. So whatever variable we want. In our case, let's just say error.
Okay.
So I'm saying, hey, if you catch type error, let us use error in our error message. So I can say here plus error. So that if I run, and let's do a string here. If I run, look at that. I get the error printed. Let me just open this up a little bit so you can see it clear. Look at that. It actually gives me the error that I want. So that I can see that on line 5, on this line, I get a type error, unsupported operand. And I get a descriptive error of what is happening.
But I didn't, wait. But where is the please enter error? Okay, trace file, unsupported operand. During handling the above exception, another E exception occurred. Okay. And there is another thing, you cannot just print out directly. Okay.
And I get a descriptive error of what is happening. So maybe I could use it in my output message. But what if I don't want to use this? And I do run. All right, everything is working. Again, if I do plus, error, and I click run. And this is actually tricky, but it says here, during handling of the above exception, which I'm doing, another exception occurred. Oh boy, I tried to handle something and I had an error within that error. So this is sometimes tricky, but what it means is what we get out here is actually an error object. It's a built-in exception in Python. You can't add in here the way I have. Instead, we want to use an f string. So I do f, and then here pass it the error. So that now, if I run this, I get please enter number, unsupported operand, type s for plus, int, and str. So I actually get this error available to me.
Okay.
Now, if I was to just print this error, let's see what it looks like.
Yeah.
Click run. You see, this is the part that we get. So it's very, very useful if you want to give meaningful errors to your users. Another interesting thing you can do is something like this, where you wrap these errors together. So let's say we have 0 division error as well.
Oh.
And here we'll just say, oops. If we, for example, divide num1 by num2, let's just run this first. I get oops. If I do 1 divided by 0, and I run this,
it's the same error.
handle multiple errors the same way.
The same way.
I can also say as error here, and just actually print out the error. And if I run this, I'll get division by 0. Or if I do a string and run this, I get the other error type. So this, again, is really useful to combine different errors if you want to handle them the same way. But what if we actually want to raise?
Wait. Go back a little bit.
I can also say as error here, and just actually print out the error. And if I run this, I get division by 0. Or if I do a string and run this, I get the other error type. So this, again, is really useful to combine different errors if you want to handle them the same way. But what if we actually want to raise our own errors? That is, we want to throw our own errors. Maybe inside of this except block, I actually want the error to display for certain types of errors. How can we do that? Let's find out in the next video.
Let's find out. Okay. Error handling.
Let's go back to our example of our game, where we have a user log in and they have to provide their age. Remember, if I click run, it's going to ask me, hey, what's your age? And if
it is a natural size. Okay.
I give it something that it doesn't like, it's going to keep asking me until I provide a proper value. There's one other piece to the try except block that we haven't covered. So we know that we have try, we have except, and then we have else. But there's also another thing called finally. And finally runs at the end after everything has been executed. So if I do print, let's say, okay, I'm finally done. Let's see what happens. If I click run here and I give it a proper age, I get thank you.
Yeah.
Try block succeeded. Nothing has failed. I go to the else and I say thank you. And now I break out of the while loop.
The while loop.
Finally says, hey, no matter what, at the end of it all, I want you to find something.
Okay.
Let's see this in action if I do something like 0. Again, please enter age higher than 0.
It executes it.
Okay, I'm finally done. But if I enter gibberish, I get, hey, please enter a number.
Finally done.
Okay, I'm finally done. So finally runs regardless at the end of everything.
Okay.
Why is this useful? Maybe you're working on a game server and you want to make sure that you log out any activity on the server. So let's say the user tries to log in, even if they try to enter the wrong information. We want to log that activity so that we can detect that there's people trying to break our program, or just to have our records that, hey, this user has tried to log in 10 times. So finally is very useful. Now, let me ask you a question. What happens if I do something like this? Let's say I have here, continue, and maybe another break statement here.
Yeah.
And then maybe inside of here, I'm also going to have a print. Can you hear me? What happens if I do something like this? Pause the video if you need to. Otherwise, I'm going to hit run and see what's going to happen. What is going to happen if I enter 0?
Okay. If you enter 0 here, it's going to divide by 0. Value error. Now it's going to enter division 0 error. You're going to print this one out. You're going to break. Wait. I think I know what's going to happen. It's going to break in division by 0, and then it's going to print out, okay, I'm finally done. And then print out, can you hear me?
Ready? I got it.
Okay, I'm finally done. And then it didn't print, can you hear me, actually?
Please enter age higher than 0, because I get a 0 division error, it catches here, and then we break out of the loop. The finally gets run.
Ah, yeah, but print because
break out of the loop.
That's inside the while true. Yeah. Okay, I'm sorry.
Remember, this is surrounded by the loop.
Yeah.
Let me remove this so we can see it better.
Yeah, thank you.
Okay. What happens if I do something like this? What if we run the program again, and this time give it gibberish?
Yeah.
Let's find out. I get, please enter a number. Okay, I'm finally done. And then what's your age? So what happened here? Well, we tried this. We got an error, a value error. It says, hey, please enter a number. And then it's going to continue. Now continue, instead of break, doesn't break out of the loop, out of the while loop. Instead, it comes back to the top. So it's going to try again this part. What's your age? Okay, so what if we finally try to log in properly and give it, hey, we're 18. What happens then? There you go.
We get the can you hear me message.
Because we've tried it, everything works, so no exception. So we're going to get thank you. And then we break out of the loop. So
we're breaking with the else.
Can you hear me? But then finally, okay, finally is done.
Yeah.
We didn't have this break statement here.
Yeah, it's going to print, can you hear me now?
Oh boy, finally, I can hear you.
Yeah.
This print finally gets printed because we don't break out of here, we don't break out of here, and then we run this line. Hopefully that makes sense. That was a bit of a trick question, but you're starting to get the hang of it. I'll see you in the next video. Bye-bye.
Okay, cancel. Well, I am about to go to the break anyway. That was exercises. Okay, I guess. I might like to at least write down this one and the previous one.
Let's try a different example here. Let's say I'm creating a simple, something like this.
Okay, so let's see. Oh, the clock is already started. Okay. I wonder what was I playing last time. I don't even remember what was doing here. Okay, Zelda. Oh, look. I was hunting seeds, I guess. I can barely remember what I was doing here. This is a story map campaign, I think. Yeah. Okay, let's go. Let's try to use our time. Okay. Okay, I already explored this part, I guess. Whoa! Yeah. Latin American Spanish is the best version for Zelda's voice, in my opinion. I am biased, maybe. Oh, look at that. There is another one here, somewhere. Uh-oh. Oh no, I got guarded. Actually, you know what? You can die now. There we go.
La victoria es mía.
Whoa. You hit me. Okay.
¡Oh, soy fuerte!
Okay, where should we go now? There is another one around here. I don't know where. No, I'm going away. There must be another seed around here, but I don't see it. Another Korak seed. Oh wait, I'm close.
¡Se acabó! ¡Al ataque! Mi poder me acompaña.
Okay, let's move. There we go. Whoa! What hit? Oh, what hit?
Protegeré. Irule. ¡Oh, soy fuerte!
No, wrong one.
Protegeré. Irule.
Yeah, I forgot how to play this game.
¡Se acabó!
No. Watch it. Oh, nice. Goodbye.
¡Un ataque perdido!
Whoa, he's really strong. Okay, now it's the bomb. Oh, never mind. Okay, run. Okay, watch it.
¡Hielo!
Okay, nice.
¡Por poco! ¡Explosión!
Okay.
¡Un ataque perdido!
Wow, he's really strong. Nope.
Protegeré. Irule.
Okay, that's my signal. Let's go back to work. Okay, so now I may like to recap the examples
and then doing something like a
again.
variable. So whatever variable we want. In our case, let's just say error. So I'm saying, hey, if you catch type error, let us use error in our error message. So I can say here plus error. So that if I run, and let's do a string here. If I run, look at that. I get the error printed. Let me just open this up a little bit so you can see here. Look at that. It actually gives me the error that I want. So that I can see that on line 5, on this line, I get a type error, unsupported operand. And I get a descriptive error of what is happening. So maybe I could use it in my output message. But what if I don't want to use it and I do run? All right, everything is working. Again, if I do plus, error, and I click run. And this is actually tricky, but it says here, during handling of the above exception, which I'm doing, another exception occurred. Oh boy, I tried to handle something and I had an error within that error. So this is sometimes tricky, but what it means is what we get out here is actually an error object.
Okay, so
It's a built-in
let's keep it running.
add in here the way I have. Instead, we want to use an F string. So I do F, and then here pass it the error. So that now, if I run this, I get please.
Now this is the code that I'm going to be writing. Okay, let's close this one. Do we have something else? No. Okay, you're going to be 02. Or maybe I should name them like this. 09 because of the section, and 02 because of the chapter number. Error handling sample with printing with variable .py, something like that. I may like to have the scripted name so I don't have to guess where is what, you know. 09 underscore. This is the first one. Okay, so what are we going to do here? I have a function called sum. 2. Here's the try. Okay, I'm going to try and just return num1 plus num2 except in this case is type error. Okay, he's going to try to catch type error here. Type error as error, because he's assigning a variable name to that. And please enter numbers. Okay. Yes. Please enter numbers. And this is going to be a formatted string. And I should just print out the error, you know. I'm going to print out 1 and 2. Okay, so let's try to do that. Python 3.09.2. And there we go. It's saying, please enter numbers. Can only concatenate a string, not int, to str. To str, none. It's not returning anything. Okay, so this is the example of how to assign a variable and use it. And I guess please enter numbers. From this point onward, this is what the error is holding. Perfect, thank you. Okay, so okay, let's try to add this change over here. This is a rename. Let's copy this relative path. There we go. And this is this one here. Okay. So now I'm going to move back to let's move to the next one. This is an exercise actually.
Please enter a number. And then it's going to continue. Now continue, instead of break, doesn't break out of the loop, out of the while loop. Instead, it comes back to the top. So it's going to, regardless, at the end of everything. Why is this useful?
I'm going to copy this one because this is important. Too bad that he didn't put that code 09_03. I wonder if it would be a better idea to just no, never mind. With finally, oh wait, maybe I should respect the snake case all the way through. There we go. And what's he doing here? I think it's the same as the first one. So I might like to copy this. Well, not the entire thing, but at least this part over here. Okay. Okay. So he's doing this thing here. But else, thank you, and it's breaking. Okay. What's the difference here? Oh, he's using the finally. And this code will run all the way. Every single execution is going to print something. This runs every time. Okay, so if I do that, it doesn't matter what happens. It's going to print every way. Okay, so let's view the terminal. 09. What? Oh, wait. Python 309 3. Oh, finally is incorrectly written. But anyway, what's your age? Let's put something else. Please enter a number, and this runs every time it's printing out. Let's try it. 1. Thank you, runs every time. Yeah, that's how finally works. Okay, got it. I just need to rename this part. Oh, I included an underscore, but I left a space there. There we go. Thank you. Okay, what else do we have?
Maybe you're working on a game server and you want to make sure that you log out any activity on the server. So let's say a user tries to log in, even if they try to enter the wrong information.
Okay, let's see the last one.
So we've just created a program that isn't going to error out, hopefully, at least with value errors and zero division errors. But sometimes errors and exceptions can be so severe that we do want to stop our programs from running. We do want to catch them like this with the except block, but at the same time, also stop whatever the program is doing. Maybe instead of print, we actually want to display that red here and says, oh, something bad's happening, stop that. Well, in that case, we either don't use the except block, or in here, we can say raise value error. Now, this is rare that you would have to do this. There are some specific use cases, but here you just write a message saying, hey, cut it out.
Oh, yeah.
So that if I run this, well, if I type in a valid number, I get, please enter a number. Okay, I'm finally done. Because I raise a value error, and it throws in here, into the except block. So I'd have to remove this. And if I remove this, like this,
oh, okay.
Enter 5, and look at that. I get a value error. Hey, cut it up. So I'm able to throw my own errors.
Oh, nice.
So this is really useful if you're creating your own library.
Okay, I'm going to, because I suspect that he's going to delete everything again. Let's copy all of this. And let's make a new one. I'm going to use 09, 04. Rising your own errors.py. Thank you. And he's rising here. How? Raise and value error. Okay. Raise, value error, and a message. So this is a function then. I'm going to raise, and value error is going to return nothing. Okay. I guess I can just print something here. Value error raised. But what he mentions here is that, let's see here. What's your age and value error? Here, in this case, it's not going to raise my own error, is it? Yeah, it didn't raise my own error. Why? Because it jumped straight to this value error, which means that these except blocks are going to have a higher priority when evaluating the actual error raising. So I need to remove this. I wonder what happens if I make this a generic one. Second argument to a division model operation was 0. Cannot appear after catch-all. Yeah, because it's a catch-all. Yeah, he's right. This will never happen because I'm catching everything here. I wonder if I can just... can I turn this like a block? Well, I guess I can just do this. Oh, wait. Just do this. There we go. Okay, looks like it's not going to. Oh wait, I need to say this one. Thank you. What's your age? There we go. It's going to raise. The value was an integer, so that's not the reason. Let's see. What's your age? 45 difference every time. That's the finally. Trace back. Okay, so it's printing the entire error. There we go. Raise value error. Value error raised. Is that the syntax? Okay, finally done. Yeah, it happened just the same, in the same way. Thank you. Okay. And then this runs every time. That's the finally. And this is the error raised. There we go. Value error raised. Oh, this is actually the message that I sent here in the end.
Or tool, and you want to let the user know that an error happened. I'm not going to keep doing what you're doing. And this could be any type of error. You can also do something like exception. And if I click run here,
A general exception.
I get an exception. Hey, cut it up. The key thing to remember with errors is that errors are unavoidable in programming. What your job is as a programmer is to be able to anticipate these errors, these bugs, these exceptions, and handle them properly in your programs. And some of the biggest errors happen when we're trying to accept input from a user, not just using this input, but functions accepting arguments, classes accepting different inputs from users like method calls, and trying to change attributes. When the outside world in our programs try to communicate with each other, errors are bound to happen. Our job as programmers is to try and code in a way that handles these exceptions gracefully, and we can anticipate these errors. There's no such thing as a perfect program. However, we can try and do our best to learn from these errors and try to manage them so that our programs don't break. I'll see you in the next one. Bye-bye.
Okay. Now generator. So this is a new chapter, right? New section. There we go. Yeah, error handling was a very short section. This is 39 minutes. Generators and generators too. Okay, so I have no idea what this is actually. The name implies that it's going to generate something, maybe values. I don't know. Okay, Fibonacci numbers. I guess it's a number generator at least because it's. I see Fibonacci here. So testing your understanding. Okay. 100 Python exercises. Oh my God, I'm not doing that. Do I? Am I? Yeah, skip because it's a lot. Yeah, that's a lot, man.
Let's talk about.
Okay, before anything else, let's see if I have something. What did I do? Okay, let's copy the relative path. That was the last. Wait, what? Oh, I forgot to add it. Okay, there we go. Now. I may like to enter Git in a bigger terminal for this one. Thank you. Git. I think I am in Git. Let me see. There we go. So this is the folder. So let's check out. So these are my last all of the commits I've been doing so far. So there is a main branch section. Let's do it the GitLab way. Let's create a git push. Let's do it the GitLab way. There we go. And this is the link to the pull request. New merge request. There we go. Okay, let's create a merge request. There we go. I may like to squash the commits. So because I like to have a clean Git history on the main branch. Close merge request. Oh, merge. There we go. There we go. Did this delete the... I wonder if the section 9 branch was deleted already? I don't think so. Into main, okay, I guess. Okay, so section 9 branch disappeared. I never saw it here anyway, so it's fine. What I should do here is to git pull maybe? I don't remember. Git branch. So it's telling me that the branch does no longer exist on the remote, so that's okay. Because I'm going to check out the main, and this is telling me I need to execute a git pull. And there we go. And getting all the changes that I did. Git log, one line, graph. And there we go. That's the section 9 branch over there. So I already had all my changes here on this one here. Git branch. I wonder if I can do this. Now, since this branch is not, well, I didn't merge it here, so I guess I can just delete it by force. Wait, it didn't find it. Let's see why. I guess it's already deleted. There we go. Okay, so let's git checkout -b to create a new branch if it doesn't exist, and you are going to be section 10. Is that right? Section 10, yes. Section 10. And there we go. I am on a new branch called section 10. Okay, thank you. Actually, I should use this this instead. Okay. Let's create. Well, I can do this. Section 10. What's the name? Oh my God, I hate Chrome. I just want to select simple stuff. Actually, I'm going to get rid of the semicolons. There we go. Oh, okay. I wonder if it would be sensible to rename these sections as, well, I don't know, maybe not now. Section 10. There we go.
Generators. A very important key term and quite an advanced topic. What are they? Generators are available in Python and allow us to generate a sequence of values over time. What does that mean? Let's explore it. You see, we've actually learned a generator before. Do you remember range? Well,
yeah.
Range is a generator. But what is that? A generator is a special type of thing in Python that allows us to use a special keyword called yield, and it can pause and resume functions. So let me demonstrate this with a nice little example. You see, when we use something like range versus something like list, let's say we convert a range into a list, like so. A list, what it does is actually create a giant list, let's say of 100 items in memory, in our computer's memory, versus a range. It creates them one by one. Let me show you. If I create a function, let's call it make list. And this make list is going to accept a number. And this make list, well, we'll say result equals an empty array. Then I'm going to say for I in range of n, we're going to add result dot append. And let's just multiply for fun I times 2.
Oh, okay.
Finally,
I
we
get
return the result.
it.
You see, when we make a list,
To return the list.
we're essentially doing this. We're using range to
Oh.
create a list and return result, which will live in memory. So let's say that here with make list, I'm going to say my list is going to equal make list 100. When I print my list and I click run, and make sure my parameter here is the right name, and make sure I can spell append.
You're not the only one.
But this list over here lives in our memory.
It's
My
a
is
list.
pointing to a location in memory.
Ah.
So this is taking up space right now. Now, range is a generator. And a generator is a little bit different because this is not being held in memory. When we do this for loop, this range doesn't create on its own a giant list of, let's say, 0 to 99, and then it starts iterating. No, with the for loop, it's going to say, hey, as a range, I'm going to give you first the number 0, then I'm going to give you the number 1, then number 2, then number 3, then number 4, all the way to 100. So in memory, it never ever creates this list like we have.
Then,
And this can get pretty hectic, right?
yeah.
Let's say we want to create a giant list now. Let's say that I want to create a list with, well, this entire array. If I wanted to, let's say, print here, this giant list, and I click run, oh boy, you see that? That's a lot of memory that I'm using up.
Yeah.
And once it's done, which it's still going, only then
Oh,
can I use this
God.
list. And it's going to access that list in memory, and then we're able to use it.
Oh,
The more
God.
efficient way is to use a generator and actually generate these one at a time without taking space in memory. Now, in order for us to learn how to do that with generators and how to actually use them, we need to go to the next lesson and revisit some old knowledge. I'm going to let this complete. In the meantime, I'll see you in the next video. Bye-bye.
Okay. Let's stop it here. Because I am about to get into my break, I guess. Okay, let's see. I don't even remember how did I get into this map. No. Whoa. There we go. Oh, it works. There we go. Oh, I level up. There we go. Now, I may like to look for the correct seed. Must be somewhere around here. It must be around here somewhere. Okay, let's listen carefully to the radar. No, I am further away. Okay, closer. Closer, getting closer. Now, can I get out of here? Yeah. Okay, where is it? It's somewhere. Wait, and closer. There is a fountain here. Hello, Impa. Wait. It must be here somewhere. Wait, I can go up and down. Must be somewhere around here. Are you here? No. Okay. Wait, here, on the light. There we go. Okay, let's go. And where I'm supposed to go now? Oh, I see. I guess I should go down here. Wait, that's the end of the mission? That's the end? No, it's too early. Ooh, you're not going anywhere. Yeah. Whoa. Ah, that's the king. Yeah. I remember that.
¡Váyanse! ¡Link! Caballero guardián de la princesa de Hyrule. Estoy convencido de que sabes cuál es tu deber.
Taking care of the princess. Ah, that's where he dies, I think.
Cuídala. Te lo ruego.
Okay, I hope I got all the carrots there. Okay. I got new materials. I think those are from the DLC. Okay, my break is over anyway. And there we go. I wonder if you can hear that now. There is a bell that rings every time. Okay, so that was an explanation for generators. Let's play the next one.
All right, this massive list finally finished being entered in memory. But remember our key terms. Remember how I said a list is an iterable? What was an iterable? Well, an iterable is any object in Python which we're able to loop through. Underneath the hood, it has the dunder iter method. So when the object is created, this iter allows us to have an iterable object that can be iterated over. To iterate something, or iteration, is the act of taking an item from an iterable, doing something to it, then going to the next one. When we use loops, like for loops or while loops, we call that iteration. It's the process itself. And generators are actually iterable. That is, everything that is a generator is iterable. You can iterate over them. But not everything that is iterable is a generator. For example, a range is a generator. So that is always going to be iterable. But a list is an iterable, but it's not a generator. So a generator is a subset of an iterable. I know those are a lot of words. Hopefully you're still with me. The difference between a generator and a regular iterable is the way we implement them. So let me show you a general way to create a generator. Let's clear this code and define our own generator. And generators are usually functions. Just like range is a function, generators are usually created this way. So let's say generator function. And this generator function is going to have a for loop that is going to loop over a range, just like we had before. But the difference here, let's actually bring back the code that we had previously. Just going to comment this out so we can see it in terms of difference. The generator function is going to create, let's say, these many items. But instead of returning like we would in a regular function, we're going to use a keyword called yield. And here, we're going to yield the I, so the item. So notice the difference here.
Yield?
Now, if we want, just like here, we can pass a number like this. But instead of returning,
go back a little bit.
This. But instead of returning like we would in a regular function, we're going to use a keyword called yield. And here, we're going to yield the I, so the item. So notice the difference here. Now, if we want, just like here, we can pass a number like this. But instead of returning and appending this list and creating all this data, we're going to use yield. Now, what does yield do? You see, yield pauses the function and comes back to it when we do something to it, which is called next, something that we'll cover shortly. So yield, it says, hey, pause the function, just yield I, give I, and when you tell me to keep going again, then I'll keep going. So how can we do this?
Oh, that's the generator.
Item in the generator function, I'm going to print the item. Now here, what's going to happen is we're going to loop over the generator
Loop over this.
and we'll give it to the generator function, let's say 1,000 for now. and we're going to print each item. In the generator function, because this is an iterable, it's going to run and it's going to loop. And for every item in this number, so that is range, we're going to yield y. So it's going to keep looping and looping. And when we come back, when we loop over, we're going to run this, and the yield comes back and runs again. Let me show you what I mean. I'm going to comment this out, comment this out as well, and just click run here. Did you see that? What we just did here is similar to down here, but instead of having to create that list in memory, it just kept going one by one. We only held one item in memory, and we used it however we wanted to. In our case, all we did was print item. Let's explore this yield keyword a little bit more. What does it actually do? Let's say that we want to multiply this by 2, just like we did here in our original example with lists. But now, instead of doing the for loop, let's just call the function and say g equals generator function, and we're going to give it 100. Now, if I print g and I click run, you see that I get a generator object. Now remember, this is just a standard way in Python that we can create a generator function using the range and the yield keyword. But this yield keyword gives us some power, because if I just return here, we're not going to get anything special.
No.
As a matter of fact, we're just going to get a value.
A value.
Instead, by using the yield keyword, what we're able to do is to turn this into a generator function that can do, well, this. I can say next g. Now, if I print next g in here and I click run, I get 0.
0.
But here's the cool part. If I do next g twice and then one time here and print it, I get. Why is
advancing?
Remember, the yield keyword pauses the function. So what just happened here is I ran the function with 100. The first item in range 100 was 0. Right? Now here, before I was even able to run this, it said, hey, this is a generator function. But the first time you run it, give the output 0 times 2. So that the very first time we run this function, and I click run, make sure we change that to y, this is just 0. If I run it again, like this, then we have, now I want you to iterate and go to 1. So 1 times 2, what is that? Well, 1 times 2, let me fix that like this. Make sure this is I get 2, because 1 times 2 is 2. If I run it again, and I click run, I get 4. You see, yield, like I said before, pauses the function and comes back to it when next is called. So if it has a yield keyword, it becomes a generator. It keeps track of this state, what we call the value, and it only keeps the most recent data in memory. For example, 4. It remembers that, because on, let's say, line 14, if I do print next g, it remembers that previously this I was, well, 4. So now, even though this piece of code already ran, if I run it on line 14, I get 6. Because 3 times 2, well, is 6. Remember, because
before you go further, because I'm guessing that you are not going to give me this code. So section 9 is over. I am on section 10 underscore 01. Generator example.py. What time is it? It's 2 p.m. already. Wow. Time flies when you're having fun. Yes. Okay, so in this case, he's creating a generator function. I think he's getting an yeah, and a for loop using the range and using the numbers parameter for the range, and he's returning yield multiplied by 2. Okay, for let's say y in the range of nums, then yield the y multiplied by 2. And then he's assigning a g variable, the generator function. And well, it's assigning this, the call to the generator function with 100 name. Okay, with 100. Okay. And now he's the function just stuck or paused on the first yield on line number 7, which means that I need to run next in order to progress in the yielding. Okay. So if I say next g and I paste this a couple of times, I'm going to get and I print the last one. If I run that, well, obviously, if I print this twice or I'm going to begin seeing how this advances. So Python 3. Wait. Oh, because I am in error handling. Wait, I said that I was going to use the actual terminal for that one. Python 3. There we go. So it's 8, 10, 12, because I'm multiplying that for 2. Okay. Okay, that's great. What else? This is a good example.
Gets multiplied by 2. So let me ask you this. If, let's say, I only do a range of 1 here, and you know what, let's just remove multiply by 2. If I do this and I run next more than once, what is going to happen?
What's going to happen? That's a good question.
I get a stop iteration. You see, next can be called as many times as we want, as many times until this range expires. And when we exceed the number of items in the range, well, we get a stop iteration error. To let us know that, hey, you can't call next anymore. We've reached the end of line. And when we use for loops with ranges, it actually detects this underneath the hood for you. So we're able to run a function like this where we use range, even though range is a generator, because the for loop automatically says, hey, I'm going to stop looping as soon as I encounter this stop iteration. But that's hidden away from us as users. Now, this concept of generators is pretty hard to understand, especially at first. So you might have to look at this a couple of times. But over the next couple of videos, I want to convince you how powerful they are. I'll see you in the next one. Bye-bye.
Okay.
Okay, I can't see you, but I know what you're feeling. You're doubting me right now. You're thinking generators are useless. You keep saying that they're fast and performant, but I don't really get it. This yield keyword and this next, and honestly, it just doesn't make sense. Let me convince you that they're true power. I'm going to select all of these and just delete them, because I want to go back to an example that we've used before. Remember when we created the decorator performance in our decorator section? Using this performance decorator, let's minimize it. I have 2 functions for us. A long time function that uses a range, and another long time function that uses a range and then converts it into a list. So remember, one creates a list, and then from that list that's created in memory on our computers, it's going to go 1 by 1 and multiply things by 5. Versus a range, which is a generator.
I'm not putting attention, I'm sorry.
Okay, I can't see you, but I know what you're feeling. You're doubting me right now. You're thinking generators are useless. You keep saying that they're fast and performant, but I don't really get it. This yield keyword and this next, and honestly, it just doesn't make sense. Let me convince you that they're true power.
Okay.
I'm going to select all of these and just delete them, because I want to go back to an example that we've used before. Remember when we created the decorator performance in our decorator section? Using this performance decorator, let's minimize it. I have 2 functions for us. A long time function that uses a range, and another long time function that uses a range and then converts it into a list. So remember, one creates a list, and then from that list that's created in memory on our computers, it's going to go 1 by 1 and multiply things by 5. Versus a range, which is a generator that comes built into Python, that is going to just 1 by 1 hold 0.
Ya hice la comida.
Okay.
Hice la comida, pero no hay tortilla.
Okay. Entonces voy por tortilla.
Pero cuando tengas tiempo, no necesariamente ahorita, pero para la hora que vayas a comer no hay tortilla.
Pues voy de una vez, porque si no, pues más tarde me va a dar más flojera.
Y luego los trastes a mí no me gusta mucho lavarlos, porque es lo único que no hago.
Ah,
Voy a barrer un poquito ahí, etcétera. Pues si me ayudas con eso,
Bueno,
bien, me voy a ocupar.
Okay, looks like I'm gonna have to leave to do chores. I'm going to pause the video here. I'm going to be back later. I need to buy some tortillas and do the dishes, you know. Thank you for coming in if you indeed are, and